Alrighty, so here are our notes on how to calculate the axis of symmetry and the vertex when only given an equation. Because we haven't learned how to graph quadratic equations, we are going to learn how to algebraically solve for these things. So, yesterday, if you were in class, we learned about a couple of features of parabolas or quadratic equations, and so we're going to review those now. So first, you need to know that the standard form of a quadratic equation is y is equal to ax squared plus bx plus c. And so with that, we have a, b, and c being just normal numbers, and then we have our variables as well. So the graph itself, when graphed, a quadratic creates a U-shaped curve called a parabola. Kind of a funny word. And something we need to know about parabolas is we're going to use our graphing calculator to sketch a few things. So let me see if I can go to my calculator. All right, so we have this y equals x squared, so x squared plus 2x minus 5. So that's going to be our first graph, and I'm going to go ahead and look at my graph. So let's see if I'm going to zoom in a little bit. Let me see if I can. I don't know why it's so big. There we go. So when we look at this graph here, we're looking at a y-intercept of -5, and we're looking for a decently narrow curve. So what we're going to do is go ahead and graph, just do a little sketch of that graph on our graph here. So here it goes. See how good it is. All right, so where our axis of symmetry, no, it's not a super straight curve, but axis of symmetry being right there at the middle, the vertex being there at the bottom. So if A, so remember, A is the number, so if I were to, this little green spot, remember there's an A here, but if it's a 1, we're not going to see a number. So if A is positive, then the parabola opens up like a smile. So, all right, let's go ahead and go back to my graphing calculator. And let's look at our second equation, which is negative, so negative x squared plus 3x plus 7. And when we look at the graph here, we see that we now have our parabola facing down, and let's go ahead and sketch that one. So again, all of these things can be looked at briefly on your calculator. So it looks like this one's going to have a more so like this with our arrows there, our axis of symmetry, which goes on forever. I should have drawn arrows on the last one. So just to fill that in, we have if A is negative, then the parabola opens down like a frown, down like a frown. Okay, so again, just emphasizing that the green spot, there is a placeholder there. There's an A there, but in this case, it's just a 1. So an axis of symmetry, I'm going to write in a definition here, is the vertical line that divides the parabola into two equal parts. So there's actually a formula, and unfortunately this one is not on your formula chart, so you're going to have to memorize it. And it is x is equal to negative b over 2a. So remember just where we're getting these from. I'm going to do some highlighting here. So if I have my b, so remember that's coming from our formula, b, and my my a is down here, and my a is up here. So that's where I'm finding these letters inside of this formula. Negative b over 2a. So remember an x equals graph. So if I were to draw I'm going to come over here. I'm just going to draw a coordinate plane really quickly. So remember, if I had, let's say this is 1 and this is 1. If I have a graph going across this 1 here, a line, this equation would be y is equal to 1. And then if I have a line at 1 going up and down, this is going to be x equals 1. So keep that in mind because our axis of symmetry is a vertical line up and down, which would be an x equals graph. All right, so the vertex, our definition here is the turning point of the parabola. Okay, when the vertex is the lowest point of the graph, like we see in this first one, we're going to call this a minimum. But in this other example here, if the vertex is at the highest point of the graph, we're going to call this a maximum. So now what we're going to do is I'm going to show you algebraically how we can calculate the axis of symmetry and the vertex with using the formula that we just learned, x is equal to negative b over 2a. So our first example, so I'm going to go ahead and write that. X is equal to negative b over 2a. So we'll calculate our axis of symmetry first because that is going to that's going to come from the x equals negative b over 2a. So our equation here that we see, y is equal to x plus 8x plus 15. So what we need to do is we need to know what b is and we need to know what a is. So in our equation, we can see here that b is a positive 8 and a is just a 1. So when we substitute this into our formula, x is equal to, I'm going to say negative. So again, there's a negative in front of the b. So I'm going to have a negative in front of that 8. And then I'm going to have that over 2 times 1. So now when I simplify this, it's going to be negative 8 over 2, which simplifies to negative 4. So our axis of symmetry line is going to be x is equal to negative 4. So here's where we're going to have to do a little more math just by substitution. So we have our original equation, y is equal to x squared plus 8x plus 15. So we know that our vertex has to be, so the vertex has to be an xy coordinate pair, an xy coordinate pair that's at the bottom or top of our graph. We just found x is equal to -4. So what we can do here is know that if x is equal to -4, what is y? So we're going to use our substitution to find what y is. So every time I see an x, I'm going to replace that with a -4. So -4 squared plus 8 times -4 plus 15. So you can simplify this all at once or individually. So I'm going to say -4 squared is a positive 16. And I just want to show you guys on the calculator. So if I type in -4 and I square it, it's going to show me that that's -16. But I know I've emphasized this a lot. We have to tell the calculator to be smart. We have to use parentheses so that the calculator knows what it is squaring. So if we see here, at the top we had -4 squared, and that was -16. But that's not what we're actually squaring. We're actually squaring the whole number -4. So we have a positive 16. And then we're going to add 8 times -4, which is a -32. So again, when we add a negative, we're just subtracting. So I'm going to go ahead and, I'm going to go ahead and erase that plus a negative because we're just subtracting. So it's 16 minus 32 plus 15. So then on our calculator or in your brain, you can say 16 minus 32 plus 15. So we have -1. So we ran out of room here. Y is equal to -1. So that goes in, and we finished our vertex. So then we're going to draw a little sketch over here. So we know that so if I'm thinking, okay, we have x is equal to -4, so 1, 2, 3, 4. So we're going to have I'm going to use red. So we're going to have a axis of symmetry at x is equal to -4. And then we know our vertex is going to be at 4, -1. -4, -1, which we see would be right here. So then that's our axis of symmetry, that's our vertex, and we know that our graph itself is positive. So we're going to draw a little parabola like this. And that is all we're asked to do. All right, moving on to the second example. I'm actually going to skip ahead. I'm going to do number 3 because this is an example where our b is negative, and I think this will help us. So on this example, we have, again, I'm going to go ahead and write our equation. X is equal to -b over 2a. So I'm going to go ahead and write from my equation here what my b and a are. So my b is equal to -12 and my a is equal to 3. So, and when we substitute these in, if I say x is equal to, I'm going to say -12 over 2 times +3. So remember, when we multiply in this example, negative times a negative, we're going to end up with a +12 over a +6, which is going to switch and make that a 2. So our axis of symmetry here is going to be x is equal to 2. So then with our vertex, we're going to use the information of x equals 2 to substitute into our original equation, which is y is equal to 3x squared minus 12x plus 5. So once we have our numbers here, we're going to say y is equal to 3 times, no longer x, but a 2 squared, minus 12 times 2 plus 5. So just the order of operations, we're going to say 2 squared is 4, and then 4 times 3 is 12, minus negative 12 times 2, so minus 24, and then plus 5. So 12 minus 24. So again, if you don't want to do this in your head, you can just use your calculator or think, okay, 12 minus 24 is negative 12, and then I'm going to add 5 to that. And that's going to give us y is equal to a negative 7. So our vertex, we know that the x value of the vertex is 2, and the y value is now going to be negative 7. So let's go ahead and sketch our little graph over here. Again, we haven't talked about how wide or narrow the parabolas are, so this is just a very general sketch. So I'm going to 1, 2, and 1, 2, 3, 4, 5, 6, 7. So my axis of symmetry is going to be at this x is equal to 2. And then our vertex is positive 2, negative 7, this dot that I drew down here. And our overall graph is positive. So I'm going to go ahead and draw my parabola this way, like that. Okay. Now, we're going to go ahead and look at, I'm going to go back to number 2, so we can look at one negative example before we end. So, again, I'm going to go ahead and write my equation one more time just so we can start memorizing it. Negative b over 2a, where our b is 10 and our a is negative 1. So now, when I substitute, I'm going to say x is equal to negative 10, but not negative 10, but you see what I wrote there, and then 2 times negative 1. So when we simplify this, it's going to be negative 10 over negative 2, which is going to simplify to a positive 5. So our axis of symmetry is a positive 5. And our vertex, we're going to use our original equation again. Y is equal to negative x squared plus 10x minus 23. So when we substitute in our 5, we're going to say y is equal to negative, and then 5 in parentheses squared, plus 10 times 5 minus 23. Again, simplifying down, I'm going to say y is equal to 5 squared is 25, so we're going to actually have a negative 25 because this negative sign is attached to the x squared in the original problem, not to the 5 that's being squared. So take note of that. Then we're going to add 10 times 5, which is 50, and then subtract 23. All right, so then let's go ahead and simplify. So negative 25 plus 50 is going to give us a positive 25, minus 23 is going to be a positive 2. So now we have our vertex being a x value of 5 and a y value of 2. All right, so then let's go ahead and sketch our graph. I'm actually not going to draw an axes because it may be an inaccurate representation. So what I'm just going to do is, we know that our axis of symmetry is going to be x is equal to 5. And we know that our vertex is going to be 5, 2. And we know that the overall graph itself is negative, so it's going to be opening down like this. So from there, those are 3 examples that hopefully will help you learn how to algebraically calculate the axis of symmetry and the vertex when given an equation like following. And one last note is that if you wanted to make sure you got the vertex correct, which would prove your axis of symmetry as well, you could take your point here and you could substitute it in for the original problem. So I actually think I'm going to do that on this first example. All right, so we got a vertex of -4, -1. So our formula here, we're going to substitute every value. So y is no longer y, it is -1. And our x is no longer x, it is -4. So then we know that -1 is equal to, so we have 16 plus 32, sorry, not plus 32, minus 32 plus 15. And we can see that 16 minus 32 is -16, plus 15 is a -1, so we have -1 is equal to -1, and so that is just one way you can check your answers if you're concerned you may have made a mistake.